assignment 6, and my partner is Dhruvi. Normally, I would do this presentation using Spider line by line, but as only the training took more than 2 hours, more than 6 hours, I will do it. I did it from notebook so we can see the outputs, and this is HTML, and I have two versions. So, as always, just started with the importance. Then I'm checking GPU. I have to do this in a virtual machine because my local machine doesn't have GPU. And because I was losing connection with the GPU, I wrote this extra code here, which is saving the model and the other parameters every 25 steps, so I can retrieve the training whenever I lose connection and have to reinitiate the virtual machine. Then again, we are using the version 3 of the environment. Then again, just checking GPU. And this is the first version where I only used 64 neurons per layer and only 2 layers. This one was not being able to solve the problem. If we watch the video, you can see it's being very slowly, and the last frame, which is this one, it's not even landing, right? So it's taking 1000 steps and not being able to solve the problem. So I came up with the second version, and for this one I increased the number of neurons to 128, and batch size I also increased. This will take advantage of the GPU. It will make more stable. Number of episodes are the same, which is the maximum for this environment. Number of steps are the same. Training start, now I'm saving 50 episodes before doing any training, so we have a range of different experiences, and training is being done every 4 steps to save a little bit of time. And gamma is 99% because we want to take in account the last step, which is the landing or crashing. And this learning rate, I increased a little bit. We started with 1 to -4. Then if we are restoring the model and arguments, if it was lose connection, right? Otherwise, we will initialize everything as 0. So all the other functions here are pretty much similar to the ones in the book. I will not take this much time because otherwise the video will be very long. But this function is just retrieving samples from the buffer. So we have 100,000 images in the experiences in the buffer, and the batch size is 128, as I said before. So it's taking random 128 experiences from there. Then the grid policy is saying, like, if we have a random number less than epsilon, and we're starting with epsilon of 1 and going down to 0.01, if I'm not mistaken. So this is the probability, and it's decreasing the probability of taking a random action. Otherwise, it will select the action with the maximum key value. Then this is the play step. We're going to select the action using this policy and provide to the environment. Then the training step, we will pick the experiences, and we are here just breaking it in different lists, doing a bunch of casts. Then we will calculate the next Q value. This is just implementation from the, I cannot change the tab here. Let's see. Implementation of this equation here. As I said, it's pretty much the same what we have in the book, which I even highlighted here. So it's implementing this equation here. And okay, this is the implementation. Then here is where we're gonna calculate the weights itself. So we're gonna calculate the loss, the target key value, and the key value itself, and then calculate the gradient based on that loss and update the weights. Then here, previously in version 1, we were using 1000. Here I'm using 700, so it decay more fast, and that's it. So, but even the training is taking 1000 steps. Only the epsilon is decaying faster. So here we are running the training. So this first part is just printing everything again if we crashed, and here is the training loop, very much similar to what we have in the book. So one loop for the episodes, one loop for the steps. Then that's what I mean that we are printing. So we are printing, here is always the last. Okay, so the fifth episode, we have 111 steps. It crashed, and keyword was this much, the time it took was this much, and the epsilon was this much. So you can see it is going down to the step 700, as I showed in the equation, and from here it's just the same all the time. Then here we are doing some analysis. All this is very well explained in the report, so I'm not taking too much time to explain. We are at 6 minutes in this explanation. So we are printing this graph. We can see at first it learned a little bit, and then it became like kind of a plateau. After 400 episodes, it started learning again, and then we reach the maximum number of points, and then this is a plateau again. And here we have the animation. You can see it will be very quickly, and it will land perfectly. Those were the total steps, reward, and it was a success. Thank you.